Okay, so yesterday you watched a video on factoring, and we really just factored the expressions to factor the expressions. But I want us to really dive into this question: what is the purpose of factoring? So if we're looking at this particular problem here, x squared plus 4x minus 60, is this an expression or an equation? If you said expression, you're correct. So it's an expression, it doesn't have an equal sign. And we find the factors of this expression. And the factors of this expression would be x plus and minus x plus 10, x minus 6. So if we're thinking about factors of 60 that add up to 4, we can find these factors. So this is just factoring to factor, but the goal of factoring is to actually solve an equation. So if we have an equation in standard form, meaning ax squared plus bx plus c equals 0, the a translates to the number in front of the x, which is 1, the b translates to the 4, and the c is negative 60. So if we think about how we can solve this equation, let's see if we can factor this expression first. So we factor this expression, and we have x plus 10, x minus 6. So I want you to think about what number for x, what could x equal in order for this entire equation to equal 0? What could x equal over here to make this entire equation equal to 0? Pause and think about it. So if x equals negative 10, then if you plug in negative 10 here, you get negative 10 plus 10, and then negative 10 minus 6 equals 0. But we know 0 times anything gives us 0. So that works. And then also, if x equals 6, we have 6 plus 10 in that first factor if we substitute, and then we have 6 minus 6. So this is 0, so anything times 0 is 0. That works as well. So if we find a solution and set this expression equal to 0, we can solve for x to find out, oh, cool, negative 10. That could be an answer. Or we could set this expression equal to 0, and we can find, nice, x equals 6. That could also work. This is called the zero product property. And if a times b times c equals 0, then in order to solve for a, b, and or c, then we can set a equal to 0, or b equal to 0, or c equal to 0. So after you factor, you're setting each factor equal to 0. So given the standard form, again, it must be in standard form. We want to find factors of the expression first, set each factor equal to 0, and then solve each equation that you created. Okay, so let's look at this one. Let's see, factors. It's in standard form, so factors of negative 28 that add up to negative 3. So we know that we have x times x gives us x squared. So factors of 28 that add up to negative 3, so if we have negative 7 plus 4, those are the factors. So now what you're doing is you're setting each expression equal to 0. So what I just did there in drawing this t-chart, I call this teeing off. And what you do, you create this t-chart to be a helpful reminder for you to set these two expressions equal to 0. So when you solve, you get x equals 7, that's one solution, and x equals negative 4, that's the other solution. So there's two possible solutions. Now let's check this. If we plugged in 7 squared minus 3 times 7 minus 28, let's see what we get. Get 49 minus 21 minus 28. We get 0. That works. And then if we plug in negative 4, we get negative 4 squared minus 3 times negative 4 minus 28. So we get 16 plus 12 when you're multiplying the negatives minus 28. So we get 28 minus 28, 0. That works. So these are two solutions. X is 7. X is negative 4. So this is using the zero product property, or ZPP for short. So let's look at these now. Do we have this first problem in standard form? We do not. So we need to rearrange this in standard form. So we have x squared minus 8x equals negative 12. And then we got to add the 12. So we get x squared minus 8x plus 12 equals 0. So we want to look for factors of 12 that add up to negative 8. So if you said x minus 6 and x minus 2, that works. So up here, when you're rearranging, you can do this all in one step, but just be careful with your signs. Just wanted you to show how you can rearrange carefully. Now, if we tee off and we say, all right, x minus 6 equals 0, what does the x equal? X can equal 6. And if we set x minus 2 equal to 0, then x can equal 2. So these are the two solutions for this equation. So let's look at this next one. We've got to subtract the 2x. So we got x squared minus 2x minus 15 equals 0. So when we're factoring here, we're left with x and x. Then factors of negative 15 that add up to negative 2, negative 5 and 3. So now we tee off, we say, okay, x minus 5 equals 0, so x can equal 5. X plus 3 equals 0, so x can equal negative 3. So you can jump ahead that way as well. So a few of the stuff you could do in your head, I'm just showing it each step so we get a little bit more comfortable and remind ourselves of this. Okay, a few more examples. So is this equation in standard form? No, so we need to rearrange it in standard form. So here's what we got to do. We actually have to multiply to then rearrange in standard form. And now we can think of factors of negative 14 that add up to negative 5. So pause and finish this one on your own. So when you solve, we should get x is 7 and x is negative 2. Okay, so I want you to pause and I want you to solve each of these. So you have to rearrange in standard form. So we should get x is 9 and x is negative 2 for that first one. And you could have rearranged it differently, and if you did that, just want to show you what that looks like. Because some of us may want to do this as their first step and subtract x squared over to the other side and add 5x, which is fine. You can do that. Negative x squared minus 7x plus 18 equals 0. But now we have this negative 1 out front. So remember, whatever you do to one side, you can do to the other. So we could always divide by negative 1 on both sides. So if we did that, we can get x squared plus 7x minus 18 equals 0. And then solve like we did above. So up to you, but make sure that this leading term is positive always before you start factoring. Otherwise, it'll get a little tricky. Okay, and then this next one, it looks like you want to divide by y, doesn't it, when you're looking at it here? But think about standard form. We need all of the terms on the same side. So we have y squared, and we can add 5y to both sides. So this is standard form, but what method can you use to factor this? Notice how you have a GCF, which is y. So we could factor out a GCF here. and then still create our t-chart. And what would y equal here? Y could equal 0, or y could equal -5. So let's think, if we plugged in 0 into this equation, would that work? 0 plus 0 equals 0? How about -5? 25 minus 25 equals 0? Yeah, they both work. So we can't forget about this y equals 0, because that's part of the solution as well. Okay, 2 more. Let's see, 2x minus 1, 6x minus 5, these equal 0. Now, it's not in standard form, but these are 2 factors set equal to 0. Can you just jump right into this zero product property? My answer is yes. Here you go. There's no need to remultiply to then refactor. But what you can do is you can solve for x in 2 separate equations. So we have x is 1/2, and then x can equal 5, 6. So there are your 2 solutions. But this second one is a little different. Notice how these factors, what do they equal? Not 0. So this one is a little different, because this one equals 0, we can say, cool, we can factor and solve. Or sorry, it's already factored, so we could just tee off and solve. This one, we can't do that. We have to remultiply everything, because this 24 here messes us up. We want to get everything in standard form first, before we look to factor. So we have to remultiply here. And then when we subtract 24, we get x squared plus 3x minus 28 equals 0. And now we can solve. X plus 7, x minus 4 equals 0. And now when we tee off, we get x is -7 and x is 4. Okay? So this one's a little tricky, so just be careful when you see problems like that. Okay, last one. I want you to try this one out, but let's think about what this means. Y plus 2 squared. Is y plus 2 times y plus 2? I want you to pause, and I want you to solve this equation. So you have to multiply, rearrange the left side, get the 34 over to the left side, set everything equal to 0 to then factor. So pause and try this problem out. So after we multiply, we get 2y squared plus 4y. And if we subtract the 34, we get minus 30 equals 0. So notice how if we divide everything by 2, we can get rid of this leading term here. So we get y squared plus 2y minus 15 equals 0. Now that's something that we can factor. So y can equal -5 and y can equal 3. Okay, so this one's very challenging because you have to do a lot of multiplication. This may take a lot for you to remember back from last year from your algebra class. So work together on your classwork tomorrow and make sure that you are uploading your classwork at the end of the period.